Okay. Okay, for this one, I'll cover a bit on the instrumentation process control. We come to chapter 2. As I explained before, by now you're supposed to cover chapter 3, which is about the valve, and we just skip this one because we have a special session with Dr. Triwahyu just now, with the staff exchange program. So I will just quickly repeat what just been explained by Dr. Wahyu. So as we know, introductions. Previously, I explained the component of instrumentation and process control. The second important components in the process control is actually the sensor. All right, the sensor is the one that will kind of the one that very important parameter to detect, to ensure that our instrumentation and process control run as per expectation, as per what we planned. Okay, of course, I don't need to describe or elaborate or define what is sensor. In general, I do believe all of you understand, even though with the simplest words about the sensor. And we have for the instrumentation and process control, there are several type of sensor that been used in practice, particularly in oil and gas. They are temperature measurement, temperature sensor, pressure sensor, flow, level, level in a tank, and many more. But we are particularly looking at only these four main, or the most commonly used in the oil and gas industry, in instrumentation and process control. All right. So okay, normally, okay, what been explained by Dr. Wahyu, normally for any sensors, they are represented by a transfer function. Okay, we have the transfer function to define any a process work, or the process control for a certain task, in which been elaborated by this transfer function. Okay, we have controller, valve, feedback process, and many more. All of these are transfer function. Gx as a function of s, etc. And we also have the control variable. Okay, we have a transfer function and control variable. And at the end, we going to establish or to represent a control system by a transfer function like this one. How it's work. Okay, so this control mechanism is achieved by combinations of transfer function and variable. We have a combination of this. Okay, this is just a block diagram or overview. Okay, what kind of equipment decision does an engineer make when designing a process or experiment? Okay, say consider this one as a example of a system. Okay, we have boiler here. For example, we have a pump, we have a valve, we have the vessel. Okay, we have the certain function or steamer here, and we have some more operation here. All right, so how this one going to regulate or to operate as what we expected? One of the important element that I suggested before, as I mentioned to you earlier, is the sensor. This is the only indicator that allowed us to control the process of this one to be operate as planned or as desired. Okay, for this one, we have a valve like F1, Okay, flow sensor. This one L2 boiler, as I mentioned. We have many more. And as engineer, we have to decide, okay, what sensor to be used for our equipment, for our process control, because there are lots of sensors to be used for as a detection system. Sometimes you may need a flow sensor, just a simple one. Sometimes you may need a flow sensor, temperature, and with additional features. We as engineer, we are the one to decide what sensors to be used for each application. What is the best valve to be used for this application? Because we need to know the spec. We need to know the criteria that to be evaluated. So we are the one to decide all of this. Okay. When you got got an employment, for example, in the company, in the company, in the industries, your project manager or your boss will simply just, okay, we want to run this one. Okay, get the quotations for temperature sensors, get the quotation from this one, and then you have to evaluate this sensor. And sometimes you may need to defend why you particularly use, or you want to go for this type of sensor, this type of sensor, this type of sensor. You need to defend because some will cost you more, some will cost you less, depending on your application. Sometimes your application is just purely on the measurement. You don't need to worry about the thermal, temperature, etc. Then it's better for you to go for the cheap one, or for the simplest one. Of course, the more advanced the sensor, the higher the price of that one. Okay, so we need to be very careful in selecting the right sensor for each of these applications. Okay. Okay. This is things that we need to consider. Do you believe in automations? Automations. Automation, what means by automation is the one that we learn in this topic. For example, we have the instrumentations, we have the actuator valve to work for us. We just design the system at the first place, and then once we design in complete system, we just monitor. We just rely on the system to alert us. Okay. Okay, Farid. Awak percaya ke automations? You trust?
Apa doktor?
Awak trust tak automation? Do you believe in automations?
Automation.
Hmm.
Belief kot doktor.
Be careful.
Belief.
Believe.
Uh-huh.
Okay. Sebab apa? You tak takut nanti automation failure, then it'll be disaster?
Sebab memudahkan kerja kot.
Mudah kerja. Okay. Zakuan?
Ya doktor.
You percaya tak automation?
Saya percaya.
Percaya Mudah kerja juga?
Apanya?
Sebab apa? Mudah kerja juga?
Dia mudahkan kerja. Kira kalau ada mesin tu mesti ada, nama mesin mesti ada kerosakan akan berlaku juga. Kita kena hadap juga.
Nak kena hadap juga betul juga tak nak kita kena live with it lah. Betul lah yang some of your suggestion just now. Whether like it or not, we have to live with it. Maksudnya contoh paling mudah kita tengok, yelah, kereta kan, sampai sekarang park assistant, lane assistant, pre-crash, all those things. Percaya tak percaya, and even sometimes we don't use it pun sebenarnya. You naik kereta yang ada pre-crash, you tak tengok pun, tapi it was there for you. Kadang-kadang for some seniors, or seniors, they would prefer to use the tak nak, dia tak pakai reverse camera, dia tak nak, dia tak confident. That is they would prefer to use the manual one. Okay, and okay, kalau you tak trust, kalau if you don't trust or if you don't rely on the automations, you may need to end up like this one. Whenever you want to check with the temperature at this point, you need to climb up the vessel, you need to rush to the site, you need to do here and that to complete all of this, which is to up to this point, it is very impractical. Okay, so like it or not, whether we trust it, the automation or not, we have to live with it. So we have to fully utilize whatever technology is there. Okay, it's just a matter if you want to reduce the risk of anything, you need to design a failure or backup system for anything that that we design or we operate. So there must be several safety procedures, several safety sensors, for example, kan, to ensure we can actually experience the failure in a very effective way. A simple one, like a warning system, so that they warn you and then you can take action accordingly. Okay, so so like it or not, we have to live with it. And sensors are everywhere nowadays, everywhere, and it's a part of a component in our daily life lah, to be honest with you, right? You, as simple as kalau contoh kata tayar pancit, sometimes instrument cluster dalam kereta tu notify you, okay, pressure, dia detect pressure difference. So dia dah detect, dia help you lah. Kalau jalan tayar pancit, rim rosak, tayar rosak kan, dia alertkan you, so that kita dapat buat preventive maintenance ke, to stop and get the things repaired ke kan, benda tu it lead to a better effective lah, cost effective indirectly. Okay, what are sensors? Okay, what are sensors? Normally it will be located at the process equipment. Okay, of course, whenever we want to monitor or detect for anything, we will place the sensor at that thing. Okay, if it is a water level, we will put in the tank. If it is a pressure sensor in the tire, they will place some sort of device, sensors in the tire, for example. Okay, we have a sensor, and they are also displayed at the equipment, and okay, the sensor is placed at the equipment on site, and on the other side, the data from the sensors will be transferred to the monitoring system, or so that we can monitor the process, the temperature, the vessel, the parameter that we're going to control remotely from control room. So we can see both. Definitely there will be gauge at the sensor that will indicate what are the current values, what are the current measurement, temperature, and all that. Okay, some values are transmitted to the centralized. Okay, so in the case of driving, if we choose this one, okay, if we try to analogy a driving as a process control, if you can see here, they have a lady driving a car here. So in this case, we can also apply the instrumentation and process control to analyze this one. Okay, sensor will be eyes. Okay, because we are driving to driving to Batu Pahat, Parit Raja to Batu Pahat, we know, then the eyes will be the sensor, to detect whether we have to brake, we have to accelerate, we have to stop, we have to turn left and right. The eyes will be the sensor. Okay. The final control element, the final control element in instrumentation case is a valve. Okay, but while driving, of course, the analogy will be this is the valve. This is the one that steer your car either going to the right or to the left, depending on the sensor. And of course, when we have this one, sensor will send the signal to the brain. This is the control unit. Control unit, so that we digest and we decide. We found about 100 meter away. The eyes look at the red traffic light. So the based on what we seen, and then it will send the signal to the brain, and it will send to main controller to decide whether we have to press the accelerate pedal or to the brake, or just release the leg. So means that all of this control system will send the signal to hand to decide to turn left, to right, or to the leg, final element, to decide whether to brake and etc. So that is how things work. Okay, process control. This is the daily life analogy to translate instrumentation and process control. Okay. Right. Okay, if we look at this one, okay, measurement are displayed either locally or in the central control room, or both. Okay. Haris, why do you think that the sensor need to be displayed at the site or at the device or equipment? I mean because we already have the control room, why we need the gauge or the display of the sensor at the site, at the tank, at the equipment? Haris?
Oh, ya dah. Sebab dia memang ada control room.
Okay.
Tapi antara control room dengan sensor dengan equipment tu pun dia still akan ada macam dia guna kabel ke untuk communicate.
Betul.
So mungkin akan berlaku error pada kabel untuk connection tu, and then bacaan pada control room lain, bacaan pada sensor tu lain.
Okay, itu awak nampak point dia macam tu Okay, good. Alamak, macam ni nak display lagi? Oh ni 23. Okay, Aiman, Safran Aiman. What do you think? Why there is a need to have the gauge ataupun the sensor gauge dekat benda tu, sedangkan dah ada control room untuk tahu value dia berapa? Safran tadi cakap apa? Takut ada failure dekat kabel kan, data lain. Awak? Aiman. Yelah, Safran Aiman.
Boleh ulang balik soalan tu? Tak berapa okey lain.
Lain tak okey? Okay, tak boleh. Lain tak okey. Tak, saya kata kenapa perlu display gauge dekat ni, macam sensor ni, kita letak sensor, kita letak gauge pula value dia. Maksudnya, in other words, awak dah letak sensor thermometer dekat sini untuk detect dia punya temperature. Thermometer tu connected to the control room. You dah boleh baca, kawan you boleh baca reading kat sini. Tapi why there is a need for you to place a gauge indicator dekat side ni, dekat tempat tu juga? Kenapa nak kena letak juga gauge yang nampak bulat you tengok penuh kan? Tak perlu letak lagi lah, sebab control room dah boleh baca. Agak-agak kenapa Wan? Wan pula. Aiman, agak-agak kenapa? Tak dengar lagi?
Tak apa jelas.
Tak apa jelas ke? Aduh. Pula alasan valid lah, nak macam ni network. Okay, Haikal boleh jawab? Haikal?
Dia WhatsApp saya doktor, katanya tempat dia hujan lebat. Dia
Oh,
tadi
ya ke?
terputus.
Okay, tak apalah. Macam mana kan?
Ya doktor. Dia
Okey, tak
WhatsApp.
apa. Ni Haikal ataupun Naim lah. Naim lah dah dia WhatsApp awak. Dia maksud dia perlukan bantuan awak lah tu Naim.
Okey doktor. Apa tadi soalan dia? Pasal
Ya Allah, awak bertanya balik.
tahu saya ni sikit tadi. Blur-blur sikit.
Blur-blur ke busy?
Tak ada, tak busy.
Paling busy manjang ni. Tak, saya tanya kenapa ada keperluan for us to place a gauge dekat sini, dekat site, dekat tank ni. Kita dah ada control room.
Untuk gauge tu, in case of control room tu ada error, so lagi satu pun orang yang memerhati tu pun mungkin dia boleh buat misjudgement kat situ. So dia kadang-kadang mungkin dia tak alert. Ada orang menjaga kan.
Okay lah. Boleh acceptable lah. Benda macam tu boleh acceptable, and kawan-kawan awak mungkin ada pandangan lain, and dia diperlukan on site ni is actually untuk ni untuk maintenance. Okay, bila dah kat control room, you dah masuk maintenance, sometimes you disconnect kan dah semua tu. Kadang-kadang you nak connectkan this one, you dah perlu tahu directly the temperature without need to rely on the control room. Kalau macam ni macam mana nak check kan, dia tak boleh nak buat maintenance. Susah.
Sebab dah cut off kan.
Quote and quote dah cut off. Mungkin dia nak tengok macam kawan kata tadi lah, there must be, you need nak buat maintenance kat tu, you nak tengok pressure, you adjust valve tu terus bagi 80 contoh kan. You boleh adjust dan nampak directly. Nanti control room ni more on monitoring sebenarnya. Monitoring, pantau ataupun untuk create the alert hazard. Okay, so there's still a need for us to place the gauge at the sensor, at the site. I mean at the tank, inside the chamber, etc. Okay, sebab setengah orang kata mungkin lah tak perlu dah kat situ dah ada control room, dah data dah transfer. So still there is a need for us on that. Okay, and then okay, what are the important features for a process control? Okay, sensor, what are the important features for process control? Untuk sensor, okay, we have this criteria. Okay, for example, we want the accuracy. Okay, of course, sensor kalau di 90 degree, you want it to show 90 darjah and 90 degrees Celsius. You don't want the sensor to show you 75, which lead to the error, which lead to the misjudgment. Okay, we want the sensor to produce as accurate as possible. Of course, these are the main criteria. Then we want the sensor to repeatability. Maksudnya means that it keep giving the right answer. It's not like once it detect this one, but the second values, which is say for example a boiling water, sekejap when you dip the sensor, kejap dia tunjuk 100 degrees Celsius. Okay, fine, that is correct. Celup sekali lagi 110 pula. Celup sekali lagi 100 80. Nampak tak? Dia tak repeatable. Dia tak boleh repeat the same accuracy. So kita perlu. Okay, reproducibility. Okay, span. Ini you tengok kriteria lah. Range. Maksudnya range. You nak detect, kita tahu dah water level ataupun yelah kita ambil boiling point of water lah, senang. Kita dah tahu boiling point mesti 100 degree Celsius. Alright? And under normal environment, it just maybe room temperature 27. Adakah you perlukan range temperature up to 1000 degree Celsius? Perlu tak? Ada keperluan tak? Tak ada kan? Maksudnya we just want the sensor, the right span, the right range, the right tolerance, so that the sensor can be functioning effectively. Maybe in the boiling case, we just need a sensor from 0 up to 100, 150 for example. We don't need higher than that. Or maybe in Malaysia, we don't go until 0 because we just have a climate tropical climate, we don't go in which the water will never go to the zero, for example. Reliability means that you really trust the sensor. For example, the one that you purchase on Shopee, 5 ringgits for one sensor, and compared to the one that you purchase made in China, to compared to the one that you purchase, for example, from Schneider, GE, General Electric, at a higher cost level. If I present to you, if I give to you these two options, okay, one is made from China, no brand, no warranty, and compared to the one that I give to you, okay, this is with 1 year warranty, the price slightly higher, and then made from etc. Of course, you from there you want to go for the other one, the one that give you warranty, because you can sort of trust of the reliability of the product. Linearity something similar to means that it can produce the same trend, the same shapes, the same the same curve, the same plot for the same conditions. Okay, we don't want under 27 degrees Celsius, sometimes the graph become curve, sometimes is exponential, sometimes is downward, upward. So we want a consistent and consistent linearity. Shape and maintenance, if possible, we want it something to be that can be maintained if possible. Some are just one off, some cannot be maintained, like once broken, once malfunctions, we just simply replace. And some of them we can actually replace one screw, one button, one etc. That can be it means that one is repairable. Okay, consistent with the process, dynamic, safety, and cost. Okay, you should be able to explain on this based on the sensors. Okay. What are the important features for process control? Okay, for example, this one, accuracy and reproducibility. Okay, degree of conformity to a standard. Maksudnya we aim for 100 degree. Temperature kita memang show 99.9, 100 and 0.1 degree Celsius. They just play around with the targeted punya value. Very accurate. Maybe the sensors too will show 97, plus minus 5. And maybe some sensors plus minus 10 degree, 10 voltage, 10 volt, or 10 millivolt. It depends to the equipment, or to the sensor, right? And reproducibility, closeness of agreement among repeated sensor output. Okay, maksudnya we want something that can reproduce again and again the same result with the same trend. Once we use the same environment, the sensor definitely will give the same result. If you change the environment, the sensor will give a new result. Okay, but consistently. So the easiest to reflect the accuracy and reproducibility is actually this one. Okay, A should be accurate. This one is not accurate, but is reproducibility. Dia maintain je dekat sini. Maksudnya, what we have to do is we need to calibrate. Because reproducibility dah okay. What we need to do is kita calibrate so that it hit the objective. And the 3 and 4 is actually, this one is not reproducibility, maksudnya, and this one pun not. This one ada accurate, tapi not reproducibility. Okay, this one not accurate and not reproducibility. This one accurate and reproducibility. This one not accurate, and this one is reproducibility. So this simple illustration should clarify to you the difference between the accuracy and the reproducibility. Okay. Okay, right. And then Okay, we have what are important features. Okay. Okay, every sensor has a zero end span. Maksudnya kita ada, macam saya kata tadi, zero end span up to 100, up to 500, up to 1000. Dia ada range dia. Of course, kalau you beli, okay, kadang-kadang kita tahu dah, macam tadi saya kata, boiling point of water memang 100 degree. So tak perlulah kita nak ambil sensor-sensor yang out of range. Kita dah tahu dah, mungkin kita ambil 80 to 120 sebab kita nak tengok the details. Okay, in general kita tahulah the larger the span, maksudnya kalau contoh kata kita ada voltmeter yang detect daripada 1 volt sampai 1 kV, bila you check certain level kadang-kadang dia tak berubah pun gauge tu kan, betul tak? Maksudnya ini tadi ukur pun macam ni pun ukur macam tu, sebabnya sensitivity level tu dah terlalu tinggi. Jadi tapi kalau you letak kita punya voltmeter range daripada 0 to 110 ataupun 15 volt, untuk electronic circuit kita boleh nampak dia keluar reading dia adalah 12.45 for example at 2 decimal place. Tapi kalau range terlalu besar, dia dah tak dapat accommodate on the accuracy. This is the role of engineer. Engineer to decide whether you want to go for accuracy or you want to go for a larger span. That's depend. That is not right. No right and wrong answer. It's actually depend on applications. Okay. Some application may need you to have a larger span. Some may need to go for accuracy. Kalau kita tengok example here, then you will see how for a system we are really dependent on the sensor here and there. We have the valve, we have the sensor. Too many sensors to detect, to ensure that our operations, the production operations, run as per expectation. Okay. Okay, there are 4 basic sensors. As I explained to you before, there are 4 basic sensors. We have a temperature, we have level, we have flow, and we have pressure. Not limited to this, but these are the main, as I mentioned, the main or the most commonly used in oil and gas industry. Definitely we'll use this one, flow, level, temperature and pressure. If you can see here, they are attached to the equipment like this one. Along the way, we have the level sensor in the vessel, we have the level, and then before it comes to motor, we have a flow sensor to ensure the flow of the fluid run smoothly, and then come to this one. Tubular, we have for example, parallel tubular reactor. Okay, reactor in which we start to heat up this oil or fluid. We have a temperature, and then here we have a pressure. There are many sensors here. Okay. Okay. Okay, we take a simple example here. Petroleum's refining process. Okay, 100,000 barrel per day of crude oil. Okay, plus minus 0.5 error in flow measurement represent about 19 million extra cost to purchaser. Okay, for example, if kita operate dalam large volume macam ni, katakan Petronas produce 100,000 barrel. In case you have error, a very small error which is less than 1%, even 0.5% error, this will lead in measurement lah, in the flow measurement. Macam ni lah, dia simple punya ni. You letak minyak dalam pump petrol. Petrol for your car. Okay, you pump in the petrol. Just imagine the flow measurement is not correct. Dia punya error dia adalah 1%. Okay, the error is 1%. Okay, you letak 1 liter, mungkin you akan kurang dapat. Sebab kan flow measurement kita dah tak betul. It's not right. So, malfunctions ataupun it's not accurate. Means that you just pump in your petrol, not even 10 liter, maybe 9.5 liters, while you are paying for 10 liters. The same goes to the owner, operator. Means that sometimes due to this error, you pump in 10 liters on digital gauge, but the one that goes into your tank is actually 11 liters. Just imagine if we are dealing with 100,000 barrels per day, this will cost millions extra cost to purchaser if they've got the shortage, and millions of extra cost to the owner if ataupun loss to the owner. That is how to describe how importance of certain sensor in a certain application, right? Maybe in this case you may need 2 or 3 sensor in the device or equipment, so that we really sure that the error is 0.001, for example, just to avoid these losses. Okay, another example, add a strong base to neutralize pH 7. Even 0.5% errors in the base flow, that represent the pH level up to 10 to 11. Maybe the acidic liquid will become alkaline. That is show how the importance of the sensor in the production, in all of the control system, instrumentation and process control. These are the significance impact toward the user, toward the customer, owner or supplier. So they need to really, or engineer need really to have a very reliable flow measurement sensor in order to eliminate these unnecessary losses to the user or the purchaser or to the seller. Okay. This control system require a flow measurements. Let's consider a situation in which the liquid is clean with the turbulent flow through the pipe. Okay, ni start kepada sensor measure ni. Okay, right. I'll just try to finish this off with this one. Okay, this topic, the last topic. I just need 5-10 minutes from you. Okay. How we measure the flow sensor? We have a liquid, we have the pump, we have the device, cooling device, we have the valve, and the most commonly used for this kind of flow sensor is actually we use the orifice meter. This is the sensor. We call it orifice meter. What is the basic principle of this sensor is that, what they do is actually, we have a tube here, and then with the tube we have a orifice plate here. Orifice plate ni, maybe ada example tak? Maybe ada example later on. Tunjuk. Orifice plate ni, you slot in the tube, and then you have a small hole, and then the water will flow. From there you can measure. You can measure the flow. How we measure? This is the process control. Now what is happened? What's happened from the sensor? We have a liquid, we have a pipeline here, and we tap the measure pressure difference. How we measure? By using the orifice plate. You can actually Google nanti. Ada dalam gambar orifice plate, nanti you akan tengok balik dalam chapter valve. Then we perform some analysis and measurement, mathematical analysis, to convert this pressure difference into flow control to control the valve, so that any difference in terms of numerical analysis here, it will feed back to the valve, and it will decide whether the valve will open or close. Okay, this one, of course, it will not shown on the process drawing, right? So it just the specification that you need to understand and to calculate externally. Okay, we have here, we have flow, we have, like I mentioned, we have the tube, and then we have a plate with a small hole that is called orifice meter. And then the water will flow through this small hole, and then the pressure difference, if you can see here, the pressure at this point is actually consistent about this one, but the moment it drop, it goes through the pressure after the orifice plate, then there will be a difference in terms of the pressure. So based on this pressure difference, the orifice plate should be able to decide what is the flow measurement. Okay. Okay, the different pressure here, like this one, okay, due to the difference, so we have delta P orifice here, so we can actually see the difference in terms of the pressure, then you can actually decide for the flow rate. Of course, this is the fundamental or the concept how they use the orifice meter to measure the flow sensor, to measure the flow rates. Okay, we have a Bernoulli equations. Okay, pressure drop, because pressure drop across a small area here, a small hole here. So based on this one, then we can measure the flow rate. Okay, Bernoulli equation will give us this general expression, and then once we install, rearrange this formula, will give you orifice meter flow, in which will give you in terms of the equation, in which PO is the average density of the fluid, and CO is the constant of the specific meter. So we don't need to worry much on the formulation. It's just a derivation how they come up with the orifice plate to detect as flow. At the end, we're going to use this formula. Okay, F equal to, okay, most common flow calculation does not require density measurement. So we rule out, we just measure the pressure 1 and pressure 2, multiply with the constant value. Okay. Okay, I leave it until at this point. You all can go through this simple work example to determine the LVDT. LVDT ni adalah linear variable differential transformer. How we perform the measurements in order to detect the measurements, or to detect the to perform the calculations. How to transform the pressure difference in term of pressure, how to convert it into volt, so that it can detect as it can be transmitted as signal to instruct the what you call it, the valve, either to operate, to open or close, to open by 1 cm or by 2 cm, by half centimeter. That is depend on this one, LVDT. So that is how we going to detect on the flow sensor. Okay, I just leave it you all at this point. Have a look, try to go through this one, because we have a work example here. I will discuss with you next week on this topic, right? On this simple example of calculations. And for this one, okay, any other questions up to this point? May I know if you have any questions?
Doktor, saya tadi nak masuk group untuk assignment tu, tapi dah penuh sebab kawan saya tadi kan dia salah masuk kan, nak keluar. Boleh boleh enable tak untuk